Now the power rules, again, we got a lot of little pieces here. Let me just fix this. There we go. We got a lot of little pieces here to look at, and I know you've seen them on the slides on the way in, but dealing with bases and exponents. So if I have a single base with two exponents, let's say that single base is a 3, and the exponents are 2 and 5. Ooh, that's an ugly looking 5. Okay, let's try this again. 3, 2, and 5. Okay. So what you have is one base, okay, and that base stays as 3. And then because you have two exponents tight together with no other bases, you have to multiply them, right? Multiply. So 2 times 5 is 10. So 3 to the 10, right? And then you have a number. You can get out your calculator and you can actually say what that is. I think it's like 59,049, something like that. But you can actually calculate that. Okay. This here, this one's generally used if you have variables. Okay. So if I have a 4x cubed, that's when you'll see something like this one used. It's saying if I have two pieces in the bracket, then this exponent applies separately to both pieces, right? It doesn't make sense if they're both numbers, like 2 and 3, because then I multiply them to get 6. So it only makes sense, this is only used, you'll see, when there's a number and a variable, right? And then what it's saying is that the exponent applies to the number, and the exponent applies to the variable, okay? And then the number we can do something with, right? 4 cubed is 4 times 4 times 4, which is 64 x cubed. And we can leave it like that, 64 x cubed, right? Can't do anything with this because we don't know what x is. Okay? The third one is when you're dividing, okay? And again, generally dealing with variables, okay? Because if I had like 12 over 3 to the 2, I wouldn't make it 12. I would say, well, 12 divided by 3 is 4, so I wouldn't need this. But if I had like 12 over y to the 2, then that's something that becomes useful and something that you'll see, okay? So then I can say this is equal to 12 to the 2 over y to the 2. And to the 2 we say squared, right? 12 squared over y squared. And we can say 12 squared is 144 over y squared, right? So it allows us to get rid of the brackets in all these cases. It allows us to get rid of the brackets. I'm really curious what 3 to the 10th is.